Hello again. Another important concept that we need to master when we analyze trusses is the concept of zero force members. It's a concept that again will save you significant time in an exam or a test, because by inspection, by applying this concept correctly, you can determine those members that have no force inside under a specific loading condition that acts on a truss. So therefore, in such cases, the members can be removed from the truss without any adverse effects on the truss. But again, this applies only for that specific force configuration. So if you change the forces that act on a truss, then that member may not be a zero force member any longer. It is very important to identify these members again by inspection, because in the end you will have fewer unknowns to solve for. So always when you try to analyze a truss, you should the first thing you have to do is to identify the zero force members. So this would be actually step 0, identifying the zero force members. But how do we go about that? Well, we have to follow the basic concept. And this concept states that if there is a joint in which two members, or actually four members, and hence four forces, act on the joint, and in pairs these forces or members are collinear, the way I'm drawing them like now, as you can see. So the blue forces FAB and FBC acting at joint B act on the same line, very important. And also FBD and FBE act also on the same line. And you can see there's nothing else acting on the joint. It's only these, nothing else. Very important again. So FAB and FBC lie on the same line. FBD and FBE are also collinear. And now the angles between these forces' lines of action can be any. So theta can be any other angle. Again, no other forces must act on the joint, no other members, nothing else. If these conditions are satisfied, then these forces are equal. FAB equals to FBC and FBD equals to FBE. And this can be very easily proven by writing the equilibrium equation for this joint, for joint B. So very importantly is that these two forces are equal in pairs, but only if the above conditions are satisfied. This is very important. Now, once we've looked at these basic concepts, we can identify two cases of zero force members. The first case is this one. So the same joint I'm drawing here, same typical joint, and FAB acts at B, and then FBD, also FBE, like so. However, there's no FBC anymore, and the angle between the lines of actions is again theta, which can be any angle. This is what is termed a T configuration, and because there is no force FBC acting here, then FAB, which would have been equal to FBC, is in this case 0. It's a T configuration because it resembles letter T, with FBD and FBE lying on the same line and FAB joining at B from a different direction. Now the second case, I'm going to use the same example, this joint B, and here is FAB acting at B, and FBD also acting at B. The angle between the lines of action of these two forces is theta, which can be again any angle. So in this case, FBC does not exist, FBE does not exist any longer. And because these were equal to FBD and FAB, the latter are zero force members. So this is termed an L configuration. There's no other force acting at this joint aside from FBD and FAB. So if there are two members like so, like these two, joining together at any angle and nothing else at that joint, again, this is an L configuration and both of these members are zero force members. These are the basic concepts. Let's look at a couple of examples now to see how we can practically identify such members. So I'm going to draw a truss, and for this truss, in this truss configuration, I'm going to apply some forces in such a manner that some members in this truss will be zero force members. So our task now, once I'm finished drawing this, is to identify the zero force members in this particular truss under the particular loading condition that I'm going to apply to this truss. So these are the joints A, B, C, D up to the end N, and let's say there's a vertical force of 10 kilonewtons acting at N, another force at H vertical with a magnitude of 30 kilonewtons, and another vertical force acting at D with a magnitude of 10 kilonewtons. So let's look at this truss and see if there are any, and if yes, how many zero force members. First of all, have a look at joint G. It looks like a T configuration, so members EG and GI lie on the same line. The member HG joins into the joint at G. There are no other forces, no other members joining here. So this is a T configuration and member HG is 0. Same at N, another T configuration, the force of 10 kilonewtons lining up with member MN, and therefore the force in member LN will be 0. We also know that the forces in the other direction are equal, so hence the force in member MN will be equal to the externally applied force of 10 kilonewtons. You can see again there's no other force applied here. Now if we look at joint B, there are two members joining together, no other forces acting on the joint, so the member forces, both members are zero force members. Now it's very important to look at the joint at one of the end of the member. It does not matter what happens at the other end of the member. So if one end of the member indicates that that member is a zero force member, then that's it. You don't have to look and get confused by what's happening at the other end of the member. So for example, in this case, member HG, we only look at joint G and we don't care what's happening at joint H, because if joint G indicates that member GH is a zero force member, then that is a zero force member. Now in the end, for this truss, we have solved for 5 unknowns by inspection out of the total number of members. So we are then done 4 zero force members, and also we determine that the force in member MN is 10 kilonewtons. I'm going to show you now another example in which I will demonstrate what is called a cascade or snowballing effect. And let's look at this big triangular truss, simply supported by a pin at A and a roller at K. And let's say we have some forces acting at E and I, and maybe, let's say another one acting where? Maybe at C and one at F. Why not? 10 kilonewtons at F vertically. How many zero force members are, if any, in this truss? Well, let's have a careful look. So if we look at joint B on the left-hand side, joint B is a T configuration. Members AB and BD lie on the same line, and member BC joining at B. That means the forces in members AB and BD are equal, and member BC is, as we've learned, a zero force member. Have a look on the right end of the truss. It's a similar situation, right? Another T configuration, same conditions apply. So another zero force member at the right end of the truss. So we have two zero force members now, FCB and FJK. They're both zero force members, equal to 0. And are we done? Well, if we look at the first glance, maybe yes, but maybe no, because now member JK, being a zero force member, can be removed from the structure. So I've just deleted it. We don't need it. I've removed it from the structure. It's a zero force member. But now if you look at joint K, you will recognize another T configuration. And as a result, the forces in members IK and KL are equal. And the force in member HK is 0. So member HK is a zero force member. We can delete that member as well from the structure. And now we look at joint H. And guess what? We determine that it's another T configuration here. So member IH is a zero force member, and the forces in members FH and HJ are also 0. So hence, by removing these unnecessary members that have 0 force, we have identified additional joints in these configurations that would lead to zero force member. So in this case, FKH is a zero force member and FHI is also a zero force member. It's a process that you would have to practice because sometimes it's not directly obvious. Often it's good to take the eraser and just remove those members that you've already identified that have 0 forces and erase them from the structure and then see if there are 0 force members due to the cascade effects. Now, on the left-hand side of the truss at joint C, can we apply the cascade effect? No, because we have the external force of 5 kilonewtons applied at joint C, and that would not be anymore a T configuration if we delete member BC. We will have 3 members joining in a truss plus the external force. Thank you very much for attending this lecture, and I will see you at the next one.